Hey guys, today I want to show you how to do things like that. Increasing servo motor, blinking, and then decreasing servo motor without actually a line of code. Let's check it. So, in order to do that, we're gonna use a library called ESPecial. It's something I've been coding and available on GitHub for the past months. It's working. Basically what it gives you is web interface like that one, a Telegram bot like that one, an API, and a MQTT client. So what we're gonna do is control that LED here on the ESP32 dev board. It has a onboard LED on the pin number 2, and we're gonna control that servo motor SG90. Which is very cheap, you can find it pretty much everywhere. And we're gonna do that without a line of code, as promised. So let's add the onboard to the control panel, the onboard LED I meant, number 2, with a pin, let's name it onboard LED, and set its input mode to output, and save it. It's gonna add a row to the control panel. Nice, and now we can control it on and off. Yeah, you can see it here, and on and off. So it's a bit slow because it's using Wi-Fi, and my Wi-Fi is using a Raspberry Pi as a hotspot, so it's very slow. So what we can do now is control that one here with the same process, adding it here with a pin 21, that's what I think it's, yeah, it's plugged on the 21, right? Call it servo, okay, and set it to analog, right? We'll keep frequency and resolution by default and set the channel to 0. Okay, save. Yeah. Now you can control the pulse width directly in the control panel. Let's set it to 3000. And see what happens. Yeah. Let's set it to 8000 and see what happens. All right. Okay, so now what we're gonna do? We're gonna increase this step by step, and then blink that, and then decrease it back to its origin. Okay, so to do that, we're gonna add an automations. First, we call it blink because we're gonna blink the LED. Repeat it 3 times because we're gonna blink 3 times. We don't have any conditions. We could have, but that's not the case. We're gonna set the GPU to onboard LED equal to 0 to set it to turn it off. And then we're gonna add a very small delay of 500 milliseconds, and then turn it on again, set GPU of onboard LED equal to 1. Okay, and then add another delay of 500 milliseconds. All right, this should be it. Save it. Now, if we press run here, just here, this should blink the onboard LED. All right. A good part of that library that you can control the automations directly via the Telegram bot. So if I press auto, it's gonna show me the list of automations I've just set, and blink is here. So if I press blink, it's gonna blink. The good stuff is that you can have that bot outside your local network on your phone, and you don't have to set any Wi-Fi port or anything to let the internet access to that small device. So that's pretty good for security, for instance. Okay, so now we're gonna control the servo motor. Servo, let's say just increase. Increase, maybe I spelled it right, yeah. We're gonna increase step by step 3 times. So let's take the value, the set GPIO pin of the servo to increase, so plus and equal 500. No, maybe 1000. It's gonna be clear. Okay, and then wait for a daily of 500 milliseconds. Okay, save it. Okay, maybe we should set it back to 1000 because otherwise it's gonna be a bit buggy. Okay, and run the increase. Let's see. Okay, it's working. Now we're gonna decrease. Decrease. Yeah. Repeat 3 times. So same thing. No conditions. Set GBO of servo to decrease 1000 by 1000. All right. And then add a delay of 500 between each decrease. Okay, save it. And then run it. All right, so now we're gonna do increase, blink, and then decrease. How we're gonna do that is editing the edit, set the next automation to be blink, save, and then the blink, we're gonna say the next automation is decrease, and then save again. All right, save. And let's do it via Telegram. So if you update the list, you're gonna see that we have a newly added automation. And then if we press increase, it does increase, then blink, and then decrease. Here we are.